Hi, my name is Jessica, and today I'll be presenting on antimicrobial resistance in vibrio cholerae, the bacterium that causes cholera. So, what is vibrio cholerae? It is a gram-negative comma-shaped bacterium. It is motile and has a single polar phagum, and people become infected when they consume contaminated food or water. It survives extremely well in aquatic environments, such as like brackish water and estuaries, and it can attach itself to plankton. Because it has an environmental reservoir, it can make it harder to fully eliminate and control. The infection causes acute watery diarrhea without treatment, and it can be fatal due to dehydration. There are two major serogroups that cause epidemics, which is the O1 and O139, and it can exchange genetic material through plasmids and integrons, which become very important for resistance. So, to the history of Vibrio cholerae, cholera has caused multiple pandemics since the 1800s. One important moment was the 1854 Broad Street outbreak in London, which helped connect contaminated water to disease transmission. And Robert Koch isolated Vibrio cholerae in 1883, which helped discover the fact that shifts medicine away from the miasma theory and towards the germ theory, which states that microbial pathogens are responsible for causing infectious disease. The seventh pandemic began in 1961 and is still ongoing today, and it has started in Indonesia and has spread throughout Asia, Africa, and the Americas. And one of the main strains responsible is the El Tor strain. Cholera has been historically influenced by global trade routes, colonial expansions, and wars and refugee movements, which are the same factors that still influence the outbreak today. The antibiotic history, they were introduced to help shorten the duration of cholera and reduce bacterial shedding. From the 1840s to the 1960s, early antibiotics like streptomycin and chloramphenicol were used along with oral rehydration therapy to replace fluids. Later on, tetracycline became the standard treatment for reduced illness duration and bacterial shedding, but resistance eventually increased. So here I have an image of all the susceptible and resistant strains, and as you can see, as time went on, less and less susceptible treatments were working. So fluoroquinolones, such as like ciprofloxacin and macrolides, like azithromycin, were then adopted because they were more effective against resistant strains. And SFX was introduced in the 1970s and was found to be just as effective in some studies. And even today, some O1 strains remain susceptible to fluoroquinolones, but this varies by region. And whole genome sequencing has become a major tool for understanding cholera resistance. It helps track global lineages and identify important resistant genes. Some commonly found genes include the SOL2, DRFA1, TET-A, and QNRVC, which reduce fluoroquinolone susceptibility. And genomic studies show that cholera strains mix genes very easily. This happens through the mobile elements like plasmids and integrative conjugative elements, which resistance spread faster. The, the mechanism of resistance, first is the efflux pumps, which push the antibiotics out of the bacterial cell. Enzymatic and inactivation or modification of the drug, the mutation of target sites so the drugs can't bind effectively, A major driver of resistance is the horizontal gene transfer through plasmids, integrons, and integrative conjugative elements. These mobile genes move easily between bacteria, especially during outbreaks, and they can also form biofilms, which make it harder for antibiotics to penetrate. Some treatments is rehydration, which is the most important one. The oral rehydration solution is the most important as IV fluids are used for severe dehydration. Antibiotics are also used in severe cases or when an outbreak is confirmed. The preferred drugs include azithromycin, doxycycline, depending on the sensitivity. Um, because resistant patterns change, it is important to monitor local trends before choosing antibiotics. Vaccines like Shankol and Dukoral help reduce the spread of infection, but long-term control still depends on preventative um, interventions such as clean water, sanitation, and hygiene. The global impact, it has been a major impact on low resource settings. Limited access to clean water, healthcare, and effective antibiotics make them more severe. And according to the World Health Organization, cholera causes around 1.3 to 4 million cases per year and between 21,000 and 143,000 deaths in endemic countries. And the global surveillance systems, including the whole genome sequencing through programs like and Glass, WHO Glass, help detect and monitor resistant strains. However, with climate change, um, population displacement, and worsening water insecurities, cholera poses like a major public health threat. So here is an image of where a cholera outbreak is still persistent, which is shown to be more in southern Africa and bits and pieces of Asia. And here is a class activity. So this will just check their understanding. So cholera remains highly treatable with oral rehydration and several antibiotics. Why do antimicrobial resistant vibrio cholera strains continue to emerge in low resource countries? So A, cholera naturally mutates faster than other bacteria. B, antibiotics are often overused or used incorrectly during outbreaks. C, resistance occurs only when vaccines fail and cholera bacteria are unaffected by sanitation conditions. And the correct answer would be B, as during outbreaks, antibiotics are frequently overused and without proper medical guidance. It creates selective pressure, which allows antimicrobial resistant cholera to survive and spread, especially in places where clean water access is limited and outbreaks can happen more often. The second one is which statement describes how Vibrio cholera develops antimicrobial resistance? A, it becomes resistant through exposure to chlorinated water. It acquires resistant genes through mobile genetic elements like plasmids and XDX elements. It forms spores that survive antibiotics, and it becomes only resistant after causing severe dehydration. And the correct answer is also B, as it acquires resistance from other bacteria through plasmids and XCX elements. Horizontal gene transfer is one of the major reasons we see the MDR resistant strains in cholera in repeated outbreaks. And here are my references, and thank you.